Okay, now objective 2 is to find the missing side of similar shapes. So example 2 says the triangles are similar. We need to find out what x is. Okay, so what do we know about similar shapes? We know that their corresponding angles are congruent, and we know their corresponding sides are proportional. Okay, so that means 15 and 5 should be proportional with 4 and 12, and 3 and whatever x is. Okay, so steps to solving these are to write a proportion to compare the sides of each shape. Alright, so we're going to compare shape 1 to shape 2. So here's shape 1, here's shape 2. Okay, and we need to compare their corresponding sides. Well, the very first thing that I want to do is figure out what x is. So I know I got to involve x from shape 2. Okay, and we're going to put that on top of a fraction, because we need to have a proportion. Well, over here for shape 1, I need to put the side that corresponds with x from shape 1. So I need to ask myself which side corresponds with x. And that's this one right here on the same side as the right angle. So 3 is the corresponding side with x. Other than that, I can pick any two corresponding sides to go with each other. Okay, and I usually like picking the numbers that are smaller. So for example, from shape 1, the next smallest number is 4. Then on the bottom over here, I have to pick the side that corresponds with 4, and that's 12. Okay, and we're setting up proportions, so we're going to set these things equal to each other. So I'm saying 3 over 4 is equal to what over 12? Alright, well, there's a couple different ways we could solve this. We could say 4 times what gives us 12 and do the same thing here. However, sometimes that's not always easy to solve that way. Okay, so we'll use the cross products method where we're going to multiply the numbers in the loop. And 12 times 3 equals 36. And then we're going to divide by the number outside the loop. And then 36 divided by 4 gives us 9. Okay? Well, then we need to make sure we answer the question. It says, find x. Well, we know x, the number, has to be 9, but we need a label. It's 9 inches. Okay, so 9 inches will hold true for those similar figures, make the sides proportional. And let's go on to our last example. Alright, example 3. An architect makes a scale drawing of a building. It says if 1 inch on the drawing represents 4 feet, then what is the scale factor from the drawing to the actual building? Okay, and then it says, what is the length and width of a room that is 4 inches by 5 inches on the drawing? Okay, so I always like to draw a picture. So here's our little drawing. Okay, and then here's our actual building. It says 1 inch on the drawing equals 4 feet on the building. Okay, the problem is we can't figure out our scale factor until we have the same units. Okay, so 1 inch is 4 feet on the building, so we need to figure out how many inches are in 4 feet. Well, 4 feet times 12 inches in a foot gives me 48 inches. So really 1 inch on the drawing is equal to 48 inches in real life. So the scale drawing, or the scale factor, is 48. Means the building is 48 times as big as the drawing. Okay? So 48 times as big as the drawing. Then it says, what is the length and width of the room that is 5 inches by 4 inches on the drawing? So, I guess I should have put this earlier. So 4 inches on this. Our drawing is 5 inches by 4 inches. They want to know what's the length and width of a room that is 5 inches by 4 inches on the drawing. Well, 1 inch was 4 feet. So if I take my 4 inches times 4 feet, that gives me 16 feet over here. So if 1 inch is equal to 4 feet, then 4 inches is equal to 16 feet. And likewise, if I take my 5 times 4, and that gives me this side of 20 feet. Okay, so the length and width, the room is 16 feet by 20 feet in real life. Okay, and again, the scale factor is 48 inches on that. Alright, if you have any questions, ask. Otherwise, good luck on the homework.